Okay, so this warm up is also the same warm up that is in the it's either 7.3 or 7.4 video. So if you want to see how to do that, you can just go ahead and go back and watch the beginning of that video. I think it might be 7.3, but these are the ones that are different. I don't know why, but we just did them all in the top left-hand corner. Anyway, okay, so I'm just going to jump right into today's stuff. So this was something that we have been doing. So remember, our goal here is we want to get it in a factored form. So we want this argument right here to be factored. And we want it to be using the factors of these numbers over here. So we can use 6, 9, 5. We have base 8, so we can do anything with base 8. So we can do base 8 of 1. We could do base 8 of 8. So we in the argument spot, we can do anything that we can do an 8 to some power. So we could do 64 if we wanted. We don't need to go that high on this problem. There isn't even a number as big as 64. And we don't even actually need any of those because just looking at it right off the bat, 54 is the same thing as 9 times 6. And 25 is the same thing as 5 times 5. So I can see right off the bat 9, 6, and 5 are all these numbers right here. So we're good to go. So we're just going to expand this out. Before I do that, though, I'm going to think of the 5 times 5 in terms of 5 to the second power, so 5 squared. Like that. Okay, so when I expand it out, it's going to be log base 8 of 9 plus log base 8 of 6 minus log base 8 of 5 squared. Okay, log base 8 of 9 happens to be the letter B. Log base 8 of 6 happens to be the letter A. And then we're going to subtract 2 because I'm going to bring that exponent, this exponent right here. I'm going to bring that out in front. So that's going to be 2. Log base 8 of 5 is C. So there's our answer, B plus A minus 2C. Now you could write that in alphabetical order if you wanted. Or you could have left it. Okay, so there's our answer. Okay, so for what value of x is this equation true? So it's an exponential, so if I want to solve it, I got to write it as a logarithm. So this is going to be log base 3 of 50 equals x. Now, most of us don't have the log. We only have log base 10 and natural log on our calculator. So log base 3, we'll have to use change of base. So we'll just rewrite this as log of 50. So change of base, I think, was a few lessons ago, over log 3 is equal to x. And now you can go to your calculator and type that in. So log 50, close your parenthesis, divided by log 3 is about 3.561. Okay, so there's our answer to that one. Okay, once again, 2 to the x minus 4 equals 100. So my variable's in the exponent spot. I can't really do anything. So that means I'm going to have to rewrite it as a logarithm. So log base 2 of 100 equals x minus 4. So once again, log base 2 of 100, I don't have a change of base button on my calculator, so I'm going to have to do it manually. So I'm going to do log of 100 divided by log 2. And so that's going to be, oops, just a minute, log 100, which is 2, divided by log 2 is about 6.644. And then I'm going to add 4 to that. And so my answer is 10.644 about. So you could go to 2 decimal places, guys, if you want. I'm just going to 3. The more decimal places you go, if you go back and check your work, like if you want to put it back in to check it, the better your answer will be. But, 2 decimal places is fine. Okay, so this one, I'm looking at it. The algebra I can do first is subtract 3. So I've got 5 to the x plus 2 equals 22. That's all I can do algebra-wise. So in order to solve for x, I cannot do anything in this form. So that means I have to convert it to logarithm form. So log base 5 of 22 equals x plus 2. So once again, we're going to have to do change of base. And then I'm going to subtract the 2. So in my calculator, I'm going to do log 22 divided by log 5, subtract 2, and that's going to be my x. So log 22 divided by log 5, and then I'm going to subtract 2. So x is approximately a negative 0.079. So remember, we can check that if we want. To check it, you would come back up here and put it back in. So you'd say 5, and then you would do a negative 0.079 plus 2 plus 3. Does that equal 25? So let's just go ahead and do a quick check. So 5 raised to the, and I'm going to do a negative 0.079 plus 2 power. And then I'm going to add 3 to that. And I get about 25.015. So, it's close to 25. We have that rounding issue. So, yep, that's close enough. That's our right answer. Okay, this one, they want you to simplify this expression as much as possible. So basically, they just kind of, some of you, like I said, might have that change of base button, but you need to know how to do the change of base formula, even if you have that button. Some of the problems on the test don't have number values, they have variables, because we want to see if you know how to use the change of base formula. So if you don't know it yet and you've been relying on your calculator, you better learn change of base, because your calculator won't do it if you have variables. It's only going to do it if you've got number values. So if we're going to do change of base, this is going to be the log of 25 divided by log 4 times log 4 over log 5. So right off the bat, I see that these two reduce. So that leaves me with log of 25 over log 5. Now, log 5 can only reduce with a log 5. So I can rewrite 25 as 5 squared. So if this is 5 squared, I could say that this is 2 times the log of 5. I just took the power that was here and I moved it out in front, okay? Over log 5. And now we can reduce the log 5s, and we end up with a final answer of 2. So that whole thing reduces to 2. So like I said, if your calculator does have that alternate base button, you still need to know change of base formula. So you should practice it whenever you can. Okay, this one we're solving for x. I noticed that I have multiple logarithms. So the first thing I'm thinking is I need to condense logarithms and see what happens. So I am going to take, operation here is a plus. So when I condense those, I am going to multiply these two arguments together. So log base 2 of 5 times x plus 8 equals log base 2 of 23. Okay, now I'm going to take a closer look and see what I've got happening. I really usually try to get it down to one logarithm. Right now I have 2, but I like this scenario. This is our 1-to-1 scenario. We have one logarithm here, log base 2, and log base 2 here. So that's all I have on either side of the equal sign. So that means the arguments have to be equal. I can do the 1-to-1 property. So I can say 5 times x plus 8 equals 23. So 5x plus 40 equals 23. Subtract 40 from both sides and you get negative 17. Divide by 5. So x equals a negative 17 over 5. Okay, that's negative, so we need to check that. So if I put negative 17 over 5 right there for x, let's just go ahead and do that. So negative 17 divided by 5, and we add 8 to that, we get 4.6. So 4.6 is okay, that's positive. Remember, we can't have the logarithm of a negative number, so this is the logarithm of our argument can't be negative. Our answer can be negative, but our argument can't be negative. So since our argument turned out to be 4.6, which is positive, a negative 17 over 5 is a good answer. Okay, so once again, I see this one. I see multiple logarithms. So I'm going to want to condense those. That's how I want to start. I notice that the sign in the middle is subtract. So that means when I condense, I am going to divide the arguments. So this is going to go the natural log of x minus 1 over x plus 1 equals 4. Okay, so it looks like I've done everything I can. I still don't know what x is. I have a logarithm and I don't know what x is, so that means in order to solve it, I'm going to have to rewrite it in exponential form. So the base here is e. So e to the 4th equals x minus 1 over x plus 1. Okay, so we need to get rid of that fraction, so I'm going to multiply both sides by x plus 1. If I do that, then that reduces. So now I have e to the 4th times x plus 1 equals x minus 1. Okay, so algebra on this gets a little bit hard if I leave it in terms of e to the 4th. So I'm actually going to finish it out in terms of e to the 4th just so you can see what an exact answer is, but I will show you what you guys can do from this step on. So right here, what you would do if you want to just leave it in terms of e is you would write it as e to the x, e to the 4th times x plus e to the 4th equals x minus 1. Then we would get the x's on the same side. And then we would get this e to the 4th to the other side with that number. I'd factor out the x. And then I would divide by this e to the 4th minus 1. Okay, this is what we call an exact answer. There's no rounding. This would be the exact answer, e raised to the 4th power. So a negative e raised to the 4th power minus 1 divided e to the 4th, subtract 1. So yeah. Oh, how did I go from a minus to a plus? Sorry, let's see. This one right here, I messed up my sign. This one right here, I subtracted over here. Oh, and then I moved it. That's how. Oh, sorry. I thought maybe I did it wrong, but we're good. Okay, if we want to not do it that way, which I think most of you don't want to, what I would do at this point in time is I would go to my calculator and figure out right here what e to the 4th is. So we're going to come over here and do it this way. This is probably what you will like better. So in your calculator, figure out what e to the 4th is. And so that's going to be like 54. So 54.598. Okay, so let's just go ahead and make that change right now. And now we'll just solve for x. So 54.598 times x is 54.598x plus 54.598 equals x minus 1. Okay, when we combine like terms, it's a little weird, but when you subtract x, remember you're just subtracting 1x. So you have 54.598. You're subtracting 1 from that. That will leave you with 53.598x plus your 54.598 equals -1. Okay, so now let's move the 54 over to the other side. So if I move the 54 over, it's going to be subtracting 54. Just think of it as the number 54. Don't worry about the decimals. So if you had a -54 and a -1, that would be a -55. So you have 53.598x equals a -55.9 or 598. I lost a decimal there. So, okay, so x is going to be a -55.598 divided by 53.598. So let's just go ahead and do that in our calculator. So a -55.598 divided by 53.598 is about a -1.037. Okay, so that's what x equals. Like I said, you guys are probably going to want to do this way instead. So making sure that you just figure out what e to whatever power is and then go from there. It's a little more straightforward. Okay, word problem. If left unchecked, a new strain of flu virus can spread from a single person very quickly. The number of people affected can be modeled using the formula P of t equals e to the 0.22t, where t represents the number of days the virus is allowed to spread unchecked. How many people will be infected after 2 weeks? Well, 2 weeks is 14 days. So we'll go ahead and put that into our formula. So you would say P of 14 equals E to the 0.22 times 14 power. So let's just go ahead and type that in our calculator. So E, and then we're going to go 0.22 times 14. And that's going to be about 21.758. So we'll just say that's about 21 people. So one person and then 21 to 21 people in 2 weeks. How many days will it take for 1,000 people to become infected? Well, we'll put 1,000, what it's equal to, that's the population it's infected now, e to the 0.22t. So remember, since we're looking for an exponential value, our variables in the exponent spot, we're going to want to rewrite that as a logarithm. You can't solve it in that format. So guys, if you get stuck and you're like, I don't know how to solve it, well, you probably just need to rewrite it into its other format then. So I'm going to do natural log since this is base E. So natural log of 1,000 equals 0.22t. So we're just going to do natural log of 1,000. And then we're going to divide that by 0.22. And that means t equals 31.39 days. So you can see how that's increasing exponentially. After 14 days, it was only 21 people, but at 31 days, which is like 10 days later, now you're at 1,000. So you went from, in 14 days, you only went to 21, but then in another 10 days later, it was up to 1,000. So you can see how that's spreading exponentially. Okay, and this is our last word problem here. Okay, so in chemistry, pH is a measure of acidity and is given by the formula pH equals a negative log of H plus, where H plus is the hydrogen ion concentration measured in moles of hydrogen per liter of solution. What is the pH of a solution that has a hydrogen ion concentration of 3.162 times 10 to the negative 7? Okay, we're just going to do a direct substitution then. of 3.162 times 10 to the negative 7. So we'll just type that into our calculator and see what we get. So negative log 3.16, oops, 162 times 10 to the negative 7. So 6.5. So a pH of 6.5. And then this one says determine the hydrogen ion concentration of a solution with a pH of 4.2. So 4.2 equals a negative log of, and here's our hydrogen ion concentration. So we'll just, let's see, we'll just go ahead and rewrite that so we can figure out what it is. So we're going to, log, remember, is base 10. So 10 to the 4.2 power, oh, wait a minute. What about their negative sign? Let's divide by the negative 1 first. Let's do all of our algebra that we can first. So this is going to be a negative 4.2 equals log, and then our hydrogen ion concentration. And now I'm going to rewrite it. 10 to negative 4.2 equals our hydrogen concentration. So 10 to the negative 4.2, let's see what that is. So that is 6.3 times 10. 1, 2, 3, 4, 5, 10 to the negative. What did I count? I'm counting my decimal places here on my screen. So negative 5. It's like 0.00063096 in my screen, but I'm going to put that in scientific notation. And so that would be moles per liter. Okay. All right, that's day 2 of solving. So remember, in a nutshell, if it's in exponential form and you can't figure it out, write it as a logarithm. If it's in logarithm form and you can't figure it out, write it in exponential. You do have your one exception of when you can use the one-to-one rule. So if you can make that exception work, do that. But otherwise, it's just write it in its alternate form.